It's great to see so many of you here. My name is Mete Atamel. I'm a developer advocate at Google, based in London.
Dzień dobry. Jestem Marc. Witam serdecznie.
I don't know what you said, but hopefully it was something good.
I'm not totally sure either, but I think I said, good morning, I'm Marc, and I welcome you to our session.
Great. So first of all, before we start our talk, you might be wondering, what's a developer advocate? One of my coworkers and a good friend of mine, Felipe Hoffa, you might know him, he basically says a developer advocate is a software engineer who has license to speak. I think that kind of captures what we do. We are software engineers by experience, but we come to events like this and talk about Google Cloud-related technologies. At the same time, we want to get your feedback and bring that back to engineering. So after this talk, we have office hours on level 3. So if you have any questions or any feedback about Google Cloud, please come and see us. So today, we're going to talk about fundamentals of Google Cloud Platform. We have a bit.ly link for the slides, so if you want the slides, just get it from there. And I've been with Google for 1.5 years, but Marc has been around more than me. I think he's been there since 2011. So Marc, you want to tell us about those good old days in 2011, how it was?
Sure. So back when I started, Google Cloud Platform was quite a bit simpler. This is actually what the platform website looked like in 2012. There were 4 products: App Engine, Compute Engine, Cloud Storage, and BigQuery. It was really nice and easy. You knew exactly which tool to use for which job. You could really get your head around the entire product offering. So those were kind of the good old days for me. This is what it's like nowadays. We have more than 60 Google Cloud product services, and so many that I can't even fit them all on one slide. So there's a lot of choices out there.
Well, that's good, right, Marc? I mean, more services, more tools, more choice, that can be only good, right?
Well, it's kind of a mixed bag, actually. The good news is we have tons of capabilities. So you can build almost anything you can imagine now. And it's a very powerful platform. But the downside is there's kind of a high cognitive load associated with all that choice. You have to actually think a little bit more and understand a little bit more to figure out which tool to use, when to use it, and how to use it. Greg Wilson came up with this chart, which I think is a really nice reference. And by the way, for anybody that is photographing, we do have these slides online right now, so we'll share this with you after feel free to photograph, but we'll share this with you. It's actually up now. But this chart summarizes every cloud product, every Google Cloud product in 4 words or less. So it's really nice synopsis. Today we're going to focus on the 4 highlighted areas. And even there, we're not going to get to go too deeply because we have 30 minutes to cover all of this stuff. And each of these products we could spend hours on. But we'll focus on those 4 areas. We'll probably touch on a few others. And we'll try to just kind of give you a high-level view, essentially a roadmap of all the capabilities of Google Cloud Platform.
All right, first let's talk about compute. I heard that in Keynote there was a compute section, so this will be a little bit of a repetition of that, but hopefully there will be some new stuff. So what we're trying to answer here is, if you have some code and you want to run on Google Cloud, what options do you have? That's what we are trying to answer. At the high level, you have 3 separate buckets when it comes to how to deploy your code. The first one is virtual machines. So you can think of these as physical machines, except they're virtualized and they're running in someone else's data center. So you can pick and choose the CPU you want, the memory you want, and then you also get to choose the operating system. It can be Linux-based or Windows-based. And then once you have the machine, you can install whatever you want. So you have full control, but at the same time, you have full responsibility with virtual machines. So virtual machines are great, but they're kind of heavyweight because you need to virtualize the whole operating system and everything that comes on top of that. So more recently, we have something called containers. So the idea with containers is that instead of virtualizing the operating system, you're virtualizing the actual process that your application runs. So you're virtualizing your application and its dependencies. This way, from there, you create a container image, and this container image is much more lightweight than virtual machines. So containers are really easy to move around. They're really fast to start. So they're a much quicker and agile way of running your applications. And if you're like me, you usually don't care about infrastructure, you don't want to care about virtual machines, you don't want to care about containers, you just want to deploy your code and let someone else manage that for you. So that's when serverless comes in. In serverless, literally just create a function, deploy it, and let someone else scale it for you, run it for you, all that kind of stuff.
So as Mete said, containers have really changed everything. And that's another thing that I've noticed over the last 5 years has had a huge impact on the entire industry and the cloud in particular. It kind of really picked up steam when Docker was released in 2013. So containers really enable a bunch of things that we didn't have before, but containers by themselves are not enough. If you think about deploying your applications in containers, these entirely self-contained modular units that you can kind of scale incrementally, it's all wonderful, but if you have a complex application with, say, a bunch of front-end servers, a bunch of back-end database servers, maybe some middleware, it's complicated to get all that stuff to work together, to monitor it, to restart things when they fail. And that's where orchestrators come in. So we've got a kind of a new breed of software, container orchestration, the most popular one being Kubernetes. And then another piece that you kind of have to reinvent if somebody hasn't created a nice pattern for you to reuse is the service access layer. So if you want to apply some security policies, telemetry, capture analytics, customize how your service is accessed, it's really nice to have a service layer on top of it. And that's what Istio is all about as a service mesh. And so the combination of all these innovations together, containers, orchestrators, and a service mesh, really gives you a very powerful way to manage and deploy your apps, especially in the cloud.
Yep, so now let's look at what you have on Google Cloud as products to deploy your applications. The first thing that you want to decide is how much customization you want and how much management you want. So there's this spectrum. The more highly managed things are, the less customizable they are usually, or if you want things to be customized, then they're not so highly managed because you have to maintain that yourself. So if you want to have things customizable, you have Compute Engine. So the idea with Compute Engine, as you heard before at the keynote, is that you get a VM with an operating system with certain CPU and memory that you choose. And then once you have that VM, it's yours. You can do whatever you want with it. So you only get like the machine and then the operating system with it. At some point, you might want to put some software on it. So one way of doing that is that you can install it yourself manually. But we also have something called Cloud Launcher. It's kind of like a marketplace for solutions to deploy to Google Cloud. So you can install things like MongoDB, ASP.NET Framework, and there's a bunch of other solutions from Google and from outside Google. So the idea of Cloud Launcher is that with one click, you can get a solution deployed to Compute Engine. So just let me show you some of this quickly. So here I am in Google Cloud Console. You've probably seen this before. On the left, we have a bunch of products on Google Cloud, but the one that we are interested in is in the Compute Engine. So on Compute Engine instance, I can see my VMs, and then these are the VMs that I have already running. If I want to create a VM, I just do create instance, and this takes me to a new page. So I'll give my instance a name. Let's call this instance GDD Krakow. And then you can choose your zone. So we have zones all over the world. But since we're in Europe, let's choose Europe West. So for machine type, you can customize it. So you can pick and choose how many cores you want and how much memory you want, all the way from 1 CPU to 64 CPUs. You can also choose already pre-configured instances. So I'm just going to choose an N1 standard, which has 1 CPU and 4 gigs of memory. After that, you can choose what kind of operating system you want. So we have all different flavors of Linux, from Debian, CoreOS, container-optimized operating systems, even Windows servers, 2008, 12, 16. You can even install applications. So if you want to have SQL Server, for example, under application images, you can install that. So I'll just choose a standard Linux instance, let's say Debian 9, and then you can allow HTTP, HTTPS, and create, and this will give me a VM within a few seconds. So I have a Linux VM already running. You can easily SSH into that. Just click this button, and you don't have to worry about keys. Everything is fully managed. So this will launch within a few seconds, and you can get into it, and you can SSH and do all that stuff. But if you're a Windows person, I have a Windows app running here. You can RDP into that. So right from the browser, just RDP, and enter my password. And then boom, you're in, and you can do all the Windows stuff that you need to do. So that's how you get VMs. But if you want to install something on these VMs, then there's Cloud Launcher. So if you go here, Cloud Launcher, this is, as I mentioned before, a marketplace for different kinds of solutions. So you can install LampStack, WordPress with one click. So let's just search for ASP.NET, because I'm a .NET guy, and I just want to install ASP.NET Framework. So this solution will give you a Windows Server, an ASP.NET Framework, IIS, and SQL Express. So I'll just say launch on Compute Engine and give this a name. So let's say ASP.NET GDD Krakow. Choose my zone as Europe West again. I'll keep my machine type as it is, and then Windows Server, I'll choose the latest one. And I'll just keep the default, hit deploy, and now this will give me a Windows Server with ASP.NET Framework and IIS and SQL Server Express deployed. So it will take a couple of minutes, but it's right there. So that's that. But as we mentioned, virtual machines, they're kind of old school now. So we have containers. And how do you run containers on Google Cloud? The easiest way to do that is App Engine. So the idea with App Engine is that you take your code, you deploy it using gcloud, and then from then on, we take that code, we create a container for it in the cloud, and then we host it on container repository, and then we deploy it to App Engine. So with App Engine, you get dashboards by default. You get versions. So every time you deploy your application, you get different versions. You get traffic splitting. So if you have multiple versions, you can split the traffic between them. And you get auto-scaling. So by default, it starts on 2 VMs, but then it can auto-scale all the way to 20. So it's very easy. It's the easiest way to start with containers on Google Cloud. But at some point, you might need more control. Sometimes you want to be able to define multiple containers, and you want to be able to scale them independently. So you basically want to create a container cluster. For that, we have Container Engine. So Container Engine is basically managed Kubernetes. So we manage the Kubernetes master for you. And with one command, you can get a Kubernetes cluster with the master and with the nodes, and then you can just use the kubectl command line tool to schedule containers. And we also have some tools around containers. So we have Container Builder, which is a way to build containers in the cloud really fast. And then we have Container Registry. So once you build your containers, they get hosted into this private space for your project. And then from there, once you have the container image, you can deploy it to Compute Engine. And then you can deploy it to App Engine, or you can deploy it to Container Engine and Compute Engine, anywhere you want, basically. So it's available to everything you have. And then finally, my favorite is Cloud Functions. So in Cloud Functions, you create a Node.js function that does some kind of functionality, and then you define what triggers that function. So it gets triggered by HTTP calls, or it gets triggered by pops-up messages. And then you just deploy that, and don't worry about containers or VMs or anything like that. Everything is fully managed for you. So let's take a quick look at these as well. So I already deployed an App Engine application, so let's just take a look at that. So if you go to App Engine, first I will click on versions, and then you can see that I have 2 versions already deployed. Let's say this version 3 is the one getting the traffic, and it's being run on 2 instances. Version 4 is not getting any traffic. I can easily change that, so I can come here, do split traffic. I will do IP-based traffic splitting, so I will just add my version and then say, let's say this will get 50%. So now each version will get 50% of the traffic, so I can do my testing and make sure that everything works. So if you go back here, you'll see that they're both getting 50% of the traffic. If I go to dashboard, this app is not being used, so you don't see much. But then under here, you see the different versions. And then I can click on the version. And then from here, I can see the latency, traffic, VM traffic. So all this stuff comes for free. You can even see the instances. So by default, the apps run on 2 instances. And these are regular VMs. You can SSH into them if you want. But you don't have to, because App Engine kind of manages this for you. And this will be auto-scaled from 2 to 20 if there's a need. So that's kind of App Engine. And then if you look at Container Engine, I can take the same container image, and I can deploy it to Container Engine and get that managed by Kubernetes. So here I have a cluster already defined. And if I look under workloads, in Kubernetes, you basically take your container and put it in what's called a pod. So I have a pod running with the same app. And then once you have your pod, you can expose that to the outside world using something called service. So with service, you get a load balancer, and then you get a public IP. So here I have the IP, and if I click on it, I have this hello world, very exciting application. But the point is that you can take the same app and basically move it around from App Engine to Container Engine really easily. And finally, what I really like is Cloud functions. So here I have a cloud function that I deployed. It's a hello world kind of cloud function. And if you click on it, it's running somewhere in the cloud. I don't know where, but I don't care anyway. And I can see the trigger. So this is a pub subtopic triggered function, meaning that if there's a topic, that it listens, and if there's a message that goes to the topic, it will be triggered. I can even see the source of it. So here, this is my function, and basically gets an event and displays the message. And you can even test it right from here. So in here, I can send a pub-sub message and say, let's say this is message, and then I'll say hello world, and then test the function. So this will invoke my function, and then when it's done, I can see the logs, I can see the output, everything right here. It's very easy, fully managed for me. So that's that. Let's go back.
So thanks, Mete. I'd like to briefly touch on something that I think is largely invisible to most people when they're using our cloud platform. When you deploy one of the computing elements that Mete just talked about, the data that's moving around either from the outside world into Google's cloud or between systems within our cloud is riding on top of the same network that powers these 7 products, each with 1 billion users. So we don't have like a separate network where we're transporting all the information for your cloud, compute elements and another network that we make really good for our own internal use. It's the same network fabric, extremely high performance, and it's the same network that's serving up all those YouTube videos, the Gmail, Google Search, Maps, etc. And the reason it's so high performance is that Google has built its own private network, massive internal private network. It contains dedicated fiber links around the world. We even own our own undersea cables. And as a result, it's not just the facilities. A ton of engineering work over the years has gone into making it very high performance, very low latency. And you're taking advantage of all that power when you're running your applications in our cloud. Another kind of key design piece of our network is that we've built it so that when users want to access our cloud platform, App Engine apps or Compute Engine or containers or any of that stuff, we've got it designed so that we route their connections to the closest point of presence to that user. The idea being that we want to get them on this high-speed Google backbone as fast as possible so that the bulk of the communication is taking place over this very optimized network. And as a result, we not only get very high throughput and low latency, but we get very predictable response time. And this is a little map of the extension of our data centers around the world. As you can see, we're in a lot of areas, but we're constantly trying to expand the footprint to accommodate platform needs all around the world. We also have several higher-end networking capabilities, which I'm not going to go into today, but we'll have some resources at the end so you can dive into those if you're interested. So we've talked about computing, and we've talked a little bit about networking, and now I want to turn to how you store your data, something every application has to do. And I'm going to try to cover everything you can do in that domain in one slide. So it's going to get a little bit busy. We have several products. It's really kind of like tools in a toolkit, and it's just some really powerful options, but it's just a matter of knowing which one to use for which situation. The very first one is in-memory storage. So this is simply caching for your App Engine app or your Compute Engine app. Think of Redis or Memcache, something along those lines, as a service. Then we have the category of relational databases, so traditional SQL-based relational databases. And we have Cloud SQL, which you can think of as managed MySQL or Postgres. So you end up with a bunch of servers where the images are maintained for you, the latest software is installed, it's backed up, but you're still thinking about database servers at the end of the day. And then we have Spanner, which kind of takes it up a level, and you really can think about just the database independent of any server. So it's really database as a service with a lot of other nice features as well. And then on the NoSQL side, we have Cloud Data Store. It's a hierarchical key value store that comes out of the App Engine world, but is now completely generalized and can be used from anywhere. And we've got Cloud Bigtable, which is also similarly schemaless and NoSQL, particularly well suited for very high capacity storage jobs. and for very high volume read and write scenarios like an event log or page views and detailed telemetry type applications. We have an object store called Google Cloud Storage. This was one of the very first products that came out as part of the Google Cloud Platform. It was the first product I worked on back in 2011. It's a very powerful binary object storage facility, global scope replication, and strong consistency. Very nice features. And then we have block storage devices. So we call these persistent disks. This is essentially a network block device for attaching to your VMs. And the idea is it's network resident, and it lives kind of its own life cycle. So if your VM goes down, or you even delete the VM, your data is still persistent on that disk. And you can get those in SSD format or spinning disks. Lots more to say about that, but I'm trying to, for time, get through it. And then, of course, BigQuery, which we'll see more in a minute, but that's a really good way to store data as well as to analyze it interactively.
Wow, that's a lot of storage options. But I keep hearing about Spanner. Can you tell us what's special about Spanner?
Funny you should ask. I actually have a slide about Spanner, Mete. Thank you. And it would have been good if I didn't advance to it early. So yeah, Cloud Spanner is this. It's very new. It was announced earlier this year, and it's really interesting new database type. It's basically a managed, unlimited scale, effectively, database as a service in the cloud. Now, whereas traditional relational databases are very strong in terms of ACID compliance and strong consistency and data semantics, but they are often difficult to scale. A lot of times you'll see companies having to shard multiple concurrent instances of an RDBMS. And whereas traditional NoSQL, rather, is just the inverse of that. So it scales very easily. You just add additional nodes to a cluster. But you often have consistency challenges, trying to make sure everything is strongly consistent and updates are seen everywhere at the same time. Spanner gives you the best of both worlds in that it gives you the scalability of a NoSQL system, and it gives you the semantics of a traditional relational database management system. And I'd like to actually just show you real quick what it looks like to work with Spanner. So this is the same platform, or same console, rather, that Mete was just showing you. But I'm in the Spanner domain. And when we're working with Spanner, we create things we call instances. And instances are simply collections of databases, but they're completely abstract. I don't have to think about how the software is configured or anything like that. Within the instance, I create a database. So I'm going to take this sort of imaginary example that I'm a university administrator, and I need to keep track of the database for all the students in the university. So I've created a database I call University. And I have two tables in that database. Departments, so these are the different subject areas. They have a department ID, a budget, and a name. And students, so these are an enumeration of all the students. So I have a department ID, which is inherited, so every student is affiliated with a department. Then I have an SID, that's my student ID, unique key for this table, and a student name. Now, one of the really nice things about Spanner is I can dynamically change the schema. Let's say I decide I want to add a column to this table, so I'll say edit schema. Anybody have something they'd like to add to the student record? What's the attribute that causes college students the most stress?
GPA.
Let's add a GPA column. Let's make it a float. We'll add that and say save. And it's now updating the schema. There can be tons of data there. It's going to update all the data that I have now, as well as make it possible for me to store new data. And the database is continuing to run. There's no downtime, so it's not stopping ongoing operations. It's continuing to serve requests as we speak. And while it's doing that schema update, I'm going to show you another thing. Let's say I'm wildly successful with my new database, and I have more load than I can possibly take. And I just told you earlier that it's really scalable. So what I can do is go to the instance page, maybe. There we go. And I can say edit instance, and I can simply change the number of nodes from 1 to 3, save. And I now have tripled my capacity that easily. I now have 3 times as much database serving capacity as I did before. So that's, I think the schema update is done, as you can see, and that being able to just turn that knob is really one of the major advantages of Spanner scalability.
All right. So now let's talk about big data in the last 4 minutes that we have. So big data at Google started with MapReduce. Back in the day, we were trying to process lots of data, and then there was a paper on MapReduce that basically explained how to take lots of data and break that down into small chunks, then map them to different machines, and then apply some kind of aggregation and get a result back. So after MapReduce, there was a lot of innovation within Google. So there were things like Bigtable, Flume, and Spanner. So these were either papers or internal implementations that people couldn't use outside Google. Because of this, we had a bunch of Apache projects that were influenced by these papers. So we had Hadoop, which is the open source MapReduce implementation. We had things like Spark and Pig and Hive. And because of this split in innovation, we have 2 products on Google Cloud. We have Dataflow, which is basically the way, the state-of-the-art data processing pipeline that came up at Google, and now we are making it available to people. But at the same time, if you are already using Hadoop and if you are already using Spark, there's something else called Cloud Data Proc. It's a way to run your Spark or Hadoop jobs on Google Cloud.
So if we think about the big data world, the typical kind of thing we want to do is to have a processing pipeline. And so I'm going to just briefly walk through that pipeline. The first phase would be capturing your data. And we'll come up with an example of how you might do this. Imagine you wanted to track all of the activity on Wikipedia. So imagine you had an event firing, like a HTTP post or something like that. Every time somebody pulled up any article in Wikipedia, Cloud Pub Sub would be a perfect example of something to use for that, because it's a very high-capacity repository. It's a message queue, and so it can then publish those events to any number of downstream consumers. We might feed that downstream into data prep, which is a way to cleanse your data and add semantic checking and rearrange things. And that might feed into data flow, which can be a very flexible pipeline building tool. You can use Apache Beam to program the processing there. And it can also operate on either large batches of data or streaming data, so you could actually use it in sort of a real-time fashion. The output of that would be the process data, and we might want to store it in one of the storage facilities I mentioned earlier. We could do real-time analysis on it using BigQuery, and I'll actually show you an example of that in a second. And then we might want to actually take that data and work on it interactively in a more user-friendly way. So we have Cloud Data Lab, which gives us the ability to use Jupyter notebooks to interactively play with the data, and we also have Data Studio, which is a very nice tool for building interactive dashboards and other visualizations. So let's hop over to the console again. This is a different part of the console, but this is for running BigQuery, and I've actually preloaded a month's worth of Wikipedia page views into this particular database. So here's my query. I can format it nicely. I'm going to turn off used cache results because I don't want to cheat. It'll come back blindingly fast, but it won't be true. So I'm going to run this query. What this is doing is scanning every line in the table of this database, and it's looking for occurrences of Krakow. Because the O can be written in different ways, depending on language, I've used a regular expression to avoid that. So not only am I scanning every row in the table, I'm running a regular expression on every single row in this table. I got my output, and if we look at the job information, we see that it scanned almost 50 gigabytes of data, and the query explanation shows us the number of rows. It scanned 1.8 billion with a B rows. Didn't just scan them all, it ran a regular expression on them all. So I hope this gives you a sense, and I didn't mention the punchline is it was under 5 seconds. In under 5 seconds, we ran regular expression queries on 1.8 billion rows of data. Hopefully that gives you a sense of some of the power and speed you'll get with BigQuery.
Great. And then last but not least, machine learning. So machine learning is big, and I think this graph shows why. This is the amount of machine learning at Google and all the different products that uses machine learning. So you can see an exponential growth in the last few years. So when it comes to using machine learning in your applications, you basically have two ways of using machine learning. The easy way is let someone build a model, machine learning model, and give you an API and use that machine learning from your application. So you're not really building machine learning yourself. You're just consuming someone else's machine learning model. And then in the other model, sometimes the given model is not good enough, or maybe you want to customize things. So you need to actually create your own machine learning model. So for that, you can create and serve your own machine learning model using things like TensorFlow. So in terms of using models at Google Cloud, we have a bunch of machine learning APIs for different kinds of models that we built over the years. So we have speech API for speech recognition, we have vision API for image recognition, and a bunch of other things. So basically, we built all these models all these years, and we are just making it available to you with an API call. And I just want to show you really quickly a demo for the vision API. So in vision API, you pass an image, and then you get information about the image using machine learning. So here I have a picture of a cute cat. Sorry for the dog lovers. I don't have a dog picture. But in this one, I pass this image to Vision API, and then I get a JSON back. But if you look at the JSON in a graphical way, the Vision API figured out that this is a cat, and it even figured out that this is a British short-haired cat. And then from there, it can extract the color. It can extract whether this is an adult image or medical image. If you pass in more complicated things, like a stadium, it figures out that it's a baseball stadium. It picks up the text from different places. It even picks up people's expressions. So it picked up this guy and then the fact that he is joyful. And it even knows where the location is. So you can see the kind of things that you can get from Vision API.
Thanks. So underlying all of those products that you saw, that exponential curve that Mete showed, is TensorFlow. And for those who haven't already encountered it, it's a framework for building machine learning models that Google open sourced almost 2 years ago. It's now become more of an industry standard, kind of communal open source project, tremendous contributions and tremendous popularity. It's particularly well suited for building complex deep learning models and neural networks and those sorts of things. And when you start to get into that domain, you really need power. You need computational power. It's not a lot of those models you can't just run on a laptop or something. And that's where Cloud Machine Learning Engine comes in. So we've built this product to make it really easy to build and serve models, TensorFlow models, in the cloud. So the idea here is you get a fully managed infrastructure. You build your model, prototype it perhaps on your workstation or wherever, and then you upload it to the cloud, and you'll benefit from very optimized environment for training and for serving your requests. The other advantage you get is the TensorFlow processing unit, which is optimized hardware we've built ourselves, custom ASICs that help do the tensor math orders of magnitude faster than we've been able to do in the past. The result of all this is that we're making it easier for people to build complex models so that you can really focus on the model and not worry about things like, where do I run it? How do I get all the CPUs I need? How do I get the GPUs? How do I coordinate parallel processing of models? A lot of that stuff's being made really easy so that you can just focus on what you care about, which is your own model.
And that's it. So that was a lot of information. The main page that you want to remember is cloud.google.com, but there's other links as well. We also have a free trial. If you want to try out, it's cloud.google.com/free. You get $300 for 12 months. So don't take our word for it. Try it out and see what you like and what you don't like.
Yeah, and I want to add that that's really the best way to learn. I mean, we're doing our best to tell you in a very short period of time what it's all about, but I find learn by doing is a great way to go. So avail yourself of the free tier, try some things out, try building something. We think you'll have a lot of fun. and maybe you'll build the next amazing application. And with that, thank you very much.
Thank you.
Dziękuję.